Greetings, everyone. Once again, I want to welcome you to my YouTube class. In today's class, we are going to be talking about another group of nematode parasites known as the tissue-dwelling nematode parasites. The tissue-dwelling nematode parasites. When we talk about the tissue-dwelling nematode parasites, we are talking about the group of nematode parasites that dwell within the deep tissues. And I'm going to be talking about or mentioning or listing some of the examples of these nematode parasites. But then let's talk about their characteristics. Now, the first characteristics of this group of parasites is the fact that they are viviparous. When we say that a parasite is viviparous, we mean that that parasite does not produce eggs, rather produces live larvae. That means that there is no part of the life cycle of this parasite where eggs are being produced. And I know I've classified the nematode parasites based on how they produce their offspring. I said that we'll have the group of nematode parasites that are said to be oviparous. We'll have those that are ovoviviparous. We'll now have those that are viviparous. So when I say that a nematode parasite is oviparous, it means that it produces eggs, and those eggs do not hatch within the body of the host. They hatch when they are within the external environment. Then we also have another group of nematode parasites that are said to be ovoviviparous. And when we say that a nematode parasite is ovoviviparous, that means that it lays eggs, but the eggs hatch within the intestine of the host before uh, going out of the external environment through the physics of course. So when you see the physics of the person who is suffering from any disease caused by an ovoviviparous parasite, you may think that that parasite is viviparous because what you're seeing is a larva, but it is not. It lays eggs, but the eggs hatch within the body of the host. And a typical example is Strongyloides saccharides, which we have studied in our previous class. Then coming to the last one, which is viviparous nematode parasites. These are the group of nematode parasites that are, of course, do not produce eggs, but produce live larvae. That is one major characteristic of tissue-dwelling nematode parasite. Another characteristic is the fact that they dwell within the uh, lymphatic system. I mean, the adult worms of this nematode parasite dwell within the lymphatic system, subcutaneous tissue, or the body cavity, And I'm going to be mentioning some of the examples of these parasites. For the lymphatic system, you're going to see parasites such as Wucheria bancrofti, Brugia malayi, Brugia timori. Then for the subcutaneous tissue, you're going to see the parasites such as Loa loa, Onchocerca volvulus, and the Dracunculus medinensis. Then for body cavity, of course, you're going to see parasites such as Mansonella streptosacca, Mansonella pastans, and Mansonella ozadi. I think I need to mention them. I need to list them so that we'll understand. So for body cavity, you have Mansonella pastans, then M ozadi, then M streptosacca. So this pastans is supposed to be here. Of course, that is how to write scientific name. But because of the fact that the space is not enough, that's why I brought it down. So Mansonella pastans, Mansonella ozadi, Mansonella streptosacca. These ones dwell within the body cavity. Then we have the lymphatic system. Within the lymphatic system, we're going to see Wucherelia, Bancrofti, Bancrofti. Then we have Brugia malayi. Then we have Brugia timori, Brugia malayi, and Brugia timori. Then what's the last one? The last one is a subcutaneous tissue. So this for subcutaneous tissue, we have loa, we have Onchozaca volvulus. Then we have the one we are studying now, Dracunculus medinensis. Then it's also important you know that man is the only significant host of these parasites. Man is the only significant host. That does not mean it does not affect other animals, but the major host it affects, is usually man. Then another thing we also should also know is that apart from Trichinella spiralis, all these tissue-dwelling nematoparasites use arthropods as their intermediate hosts. For instance, you see that Wuchereria bancrofti use different species of mosquito. Loa uses the mangrove flies or the cresop. Then Onchozaca volvulus uses the Simulum damnosum, that's a black fly. Then Dracunculus medinensis uses the cyclop. So you can see that all the nematoparasites, all the tissue-dwelling nematoparasites use arthropod. The only one that does not use arthropod as its intermediate host is the Trichinella spiralis. Okay, let's now go into a detailed study of Dracuculus medinensis. This Dracuculus medinensis is also called the guinea worm or the Medina worm. Some people call it the fiery serpent. The fiery serpent. Now, this is one of the oldest nematoparasites known to man, and is one of the parasites, if not the only parasite mentioned in the scripture uh, back in the days of the children of Israel when they sinned against God. And God now told Moses to lift up a serpent, and that anybody who looked at the serpent will be made whole. Now, theologians have come to tell us that that serpent that God told Moses to lift up was Dracunculus medinensis, or the fiery serpent, or the Medina worm, or the guinea worm. This parasite is mostly distributed in India, in Pakistan, within the Middle East, and in so many countries in Africa. And the parasite is very large. As a matter of fact, Dracunculus medinensis is the largest nematoparasite that affects man. Remember, that affects man. We have another one which is larger, which I mentioned in the previous class, that affects the sperm whales. So, but when it comes to man, it's the largest. The length is about 80 to 90 cm. You can see how huge or big this parasite is. Okay, we'll go into the life cycle of Dracunculus medinensis. Now, the life cycle of Dracunculus medinensis begins by the ingestion of the arthropod intermediate tooth, which is called a cyclop. The cyclop. Now, once this cyclop is ingested, either in a shallow stream or shallow well, such an individual goes to fetch water which has been contaminated with the cyclop, And of course, this cyclops is carrying the L1 of this parasite. So once it is ingested, the larva is released into the small intestine or within the duodenum. Of course, it migrates through the mucosa and the submucosa of the small intestine and joins circulation. And it goes directly into what we call the axillary and the inguinal region. mm, Within the armpit and within the groin, that is where this parasite migrates to. And within this region, they molt severally to become adults. Remember, the L1 is found within the cyclop, and once they get within this inguinal or the axillary region, then they molt severally from L1 to L2, from L2 to L3, from L3 to L4, and from L4 to adult. And once they become adults, the males and the females will mate. After mating, the gravid female, which is now the female carrying the larva, will migrate to the extreme part of the body, usually to the extreme part of the skin, usually that of the limbs, the hand or the legs. That is where they migrate. So those within this armpit migrate towards the skin of the hand, while those within the groin region migrate towards the extreme part of the leg, the skin of the leg, the extreme part. Now, within this region, and of course, it takes about a period of 1 year before they mature into adults from L1 to adult. Now, by the time these female worms that are carrying the larva, by the time they migrate towards the extreme part of the skin of the limbs, then we are told or we know that there's usually what we call internal contraction pressure. Because of the amount of larva that this parasite is carrying, it kind of increases the pressure within the body of the parasite. And progressive senility too, apart from internal contraction pressure, we also have what is called progressive senility. As the parasite ages, the the body wall and the uterus begin to weaken, with the fact that there is also a kind of pressure that it is going through as a result of the mini larva is carrying. So these two factors will now result to the breaking or the bursting of the parasite within the anterior region. Within the anterior region. So within the anterior region, that is where the parasite will now burst. And once it bursts, it forms a blister within that region of the hand. So what the parasite does is to burst and possibly cause a blister, a kind of lesion or wound within that part of the body where it will come out from. So once that individual, because what the parasite does is that it actually, forces the individual to a kind of dip that's part of the body within water, because that is how the parasite can escape and propagate its life cycle. So a drop in temperature of the host, a drop in the temperature of the host, that is when there's a reduction in temperature of the host. And what I mean is that because of the hotness that this parasite creates within the host, then that host will feel like or will feel compelled to dip that part of the body within water. It could be in the stream, the person can go to the stream to do that, or anyhow. But once it happens, then it triggers the release of the larva. And as the larvae are being released into that aquatic environment, if there are cyclops, this arthropod called cyclop, within that aquatic environment, then that cyclop will kind of ingest the larva within the period of about 4 to 7 days. If it does not see any, if the cyclop if the cyclops do not ingest the larva within this period, 4 to 7 days, then of course the larva dies. But if they ingest it, then within the cyclop, the parasite, I mean the larva, gets into the cyclop, and until the individual, when next the individual ingests the cyclop, then the cyclop will now be digested and be released into the small intestine again, and the cycle continues. So this is basically the life cycle of Dracunculus medinensis. So let me go through them again. Ingestion of a cyclop, then the cyclop gets digested, the larva is released, the larva joins circulation, goes through the axillary and engineering region, where they morph severally to become adults within a year, and mating occurs. The pregnant or the gravid female migrates to the extreme part of the limb. That is where internal contraction and progressive senility uh, with a drop in temperature of the host causes the bursting of the parasite within the anterior region, and of course blister is formed, and the individual is forced to dip that part of the body in the water, and that triggers the release of the larva. Cyclop ingests the larva, and the cycle continues. So that's it about the life cycle of Dracunculus medinensis. Having known this life cycle, the next thing to talk about is treatment. How do we treat? Okay, yes, let's talk about treatment. How do we treat this Dracunculiasis? The name of the disease is Dracunculiasis. It causes a disease called Dracunculiasis. Okay, but before we talk about disease, let's talk about pathology. What does it cause? Yes, it's important we talk about pathology. Then, of course, without saying much, you should know that the adult worm or the parasite, causes a big lesion, wound within that part of the body. Of course, you should know that those that are not able to escape degenerate and are being absorbed by the body of the host. Then the ones, can you see how long this parasite is? How huge it is? So it causes lesion in that part of the body. And sometimes the person may even be, you know, may have tetanus or may develop tetanus as a result of the opening that it has created. Then, if a joint is, uh, you know, if the exploration of the parasite, or probably that part of the body where the parasite emerges from, if it's within a joint, of course, it can cause a kind of arthritis within that region, and so many other things that this parasite can cause. So the parasite, does a huge harm to that part of the body. If it's in the hand, it does a huge harm. If it's in the leg, it does a huge harm. All right. Now we can now go into treatment. How do we treat this parasite? How do we treat this parasite? It's important to know that there is a superstitious belief around this parasite. Some people believe, and that is because of the pain it causes. It causes excruciating pain. Some people believe that anybody who comes down with this disease, or anybody who is suffering from this disease, is being punished by the gods. Treating this parasite is not an easy one. The first thing you do is to gradually, use a stick to unwind the parasite, and this thing can take a period of 2 weeks. Yes, I'm saying 2 weeks, or sometimes even 3 weeks, because you have to tie the stick to a soft rope, and tie the anterior part of the parasite, and you begin to unwind it, begin to you know remove it little by little. If you do it by force, then of course the parasite will uh, kind of break, will cut. The anterior part. So you don't tight the rope will not be so strong on the body of the parasite, but at the same time you should be able to grip it in such a way that you'll be taking out the parasite little by little, little by little. So once you're done taking the parasite away, and of course, while sleeping, during the process of taking away, you don't sleep normally. You have to, the leg has to be positioned on the bed in such a way that it does not, cut the parasite. So this is a very tedious process. It's very tedious, and it causes excruciating pain. The pain is a deep one. Okay, so once you're done removing the adult worm from the body, the next thing to do for people who don't want stress, they can also use surgical method. Remember, I said that that parasite is usually found at the extreme part of the skin, and maybe the hand or the leg. So one can use surgical method, to cut that part of the skin and remove it and stitch it back. So, but for people who don't have money, the only way is to gradually take out the worm from the body. So it causes excruciating pain. And uh, once you're done removing the parasite, then the next thing to do is to take antibiotics. Antibiotics that we, of course, you know, uh, help in healing the secondary bacterial infection, which was part of the effect of the parasite. I didn't mention it. This parasite can cause a secondary bacterial infection. When a bacteria infects the internal part of the body that is already open, or where lesion has occurred, once bacteria are infecting that part of the body, that is what we call the secondary bacterial infection. So this secondary bacterial infection can also, be accompanied by cellulitis, and septicemia. Septicemia is a poisoning of the blood. The blood, the bacteria can get into the blood stream, because the blood vessels have been tampered with. The integrity of the blood vessels have been tampered with. So bacteria can get into the blood through that means and poison the blood. That's what we call blood poisoning, septicemia. Septicemia, blood poisoning, septicemia. So this is one of the reasons you take antibiotics after removing the worm to kill some of those bacteria that have caused these issues within the body. Okay, that is for treatment. Then epidemiology, the spread of the disease is enhanced by the uh, presence of the intermediate host, then presence of uh, the presence of intermediate host, then aquatic environment, and the contact of man with infected water. So man must make contact with infected water. So these are the three factors that help to spread the disease. If man does not make contact with the infected water, of course, this disease cannot be perpetuated. But once man makes contact, and of course there's an aquatic environment and there's an intermediate host. If there's no intermediate host, of course, it will also not help in the life cycle, because without the cycle of intermediate host, the life cycle cannot be propagated. So it requires the intermediate host or the cyclop before the life cycle can continue. So these are the three epidemiological factors that help in the spread of the disease. Then diagnosis. Like I said, the this parasite is said to, the disease, sorry, is said to be superstitious. So anyone who is suffering from the disease, people feel the person is being punished by the gods or one deity like that. But that is actually not the case. This is a normal disease that can affect people within some region, within some region. And I've mentioned some of these regions, where they don't take the issue of personal hygiene seriously. And we'll still talk about that under prevention and control. Some of the factors that can result to the propagation of this parasite or the disease. So, diagnosis, if you want to diagnose this parasite, so what you do is that you drop it, you put a drop of water on that part of the skin where the parasite is about to emerge from, instead of going to the stream. Because if you go into the stream, you're helping to you know the parasite to continue its life cycle. So what you now do is to probably get a basin of water and dip that part of of the body into the water. Then you're going to see the parasite, the larva emerging from the anterior part of the parasite. Then one can collect those larvae, put on a slide, and view under the microscope. With that, you should be able to know if the larva are larva of a Dracunculus medinensis, or you can diagnose the disease through that method. So, diagnosis, sorry, is through the demonstration or the presence of larva on the sample that has been collected. So that is how you do it. Place, or you can even place a drop of water on that part of the body. Once a parasite notices a drop in temperature, once it notices a drop in temperature, then it begins to release the larva. Then you can use a slide to collect the larva and view under the microscope. As simple as that. Then prevention and control. Pipe-borne water should be installed. The government should do this. Make sure that they install a pipe-borne water. And public education. People should be educated about this parasite, because it's ignorance that will make people that to think that a god is pursuing them or a god is punishing them when they encounter such a disease. And of course, if you must drink water within the aquatic environment that has been suspected to be infected, then of course you must boil, so that that boiling, that heat can kill the cyclone on the intermediate host. So we have other methods. So this is where we end the class for today. So we're done with the teaching on Dracuculus medinensis. The next tissue-dwelling parasite, which may be the last we're going to be talking about, is the filarial worms. The filarial worms. Under the filarial worms, we are going to crisscross the Wucheria bancrofti, the Brugia malayi, Brugia tumori, and Onkosaka populus lualua, and that will be all for nematode parasites we have been studying. Once more, thank you for being part of my class, and I'd like you to share this video to other medical students all over the world if you will benefit from this. I still remain Dr. Anubujo Anuchena. See you in my next class.